All right, welcome to day 2. Sorry I put up day 3's PowerPoint presentation first. I literally just flew back from Seattle about 5 hours ago, and I hate red eyes, and I got about this much sleep. So if I fall over, it's probably not a heart attack. It's probably I'm just like so tired. But you should still call 911. This is Marcella. She's a senior this year, and you should only hope to be as smart and as good at computer science as she is by the time you get done with your Tufts education. She's going to do amazing things going forward, so you should get to know her. She's about to talk about the Computer Science Exchange and what that means for you and what it is. And she asked me to just chat for a couple minutes so you could get a little background on it so that hopefully you can participate. Over to you.
Thank you. Hi everyone. My name is Marcella. I think I've met a reasonable number of you by Comp 11 before. So I do Comp 11, but I'm also president of the Computer Science Exchange, which is our undergrad computer science group on campus. And the goal of the group is to give you all the stuff that you aren't getting from the department, like real world skills, how to use things, how to do interviews, and also to help you build a community so that you meet and hang out with other CS students, which is actually fun, I promise. So we're starting out this semester with our general interest meeting. It's going to be on a Wednesday during the open block. That's the usual time for all of our meetings. And we're just going to hang out and talk about some of the stuff we have planned for the semester. We've got a bunch of special interest groups. We've got like Data Science Club and Web Dev specific groups if you want to learn more about that, and all sorts of other interesting events that are going to happen. If you also want to come and tell us what other things you want to learn about this year, this is a great opportunity to do it. If you also want to come and eat pizza, this is a fantastic opportunity to do it. So I put the details there. It's Wednesday at noon. It's in Halligan. It'll be super fun. So if y'all want to come and just hang out, meet some CompSci kids, and hear about some of the stuff that we're going to be doing this year, you're welcome. You're also, check out our Facebook page, and if you want to get on our e-list, send a message to that page. And you'll get all these emails from me, which are super fun to get. Okay, any questions? Who's coming? Good, got some. Bring your friends. Thanks, guys.
All right, thanks, Marcel. OK, welcome to day 2. So first things first, what questions do you have right now before we begin? Yeah.
When do you think the TA hours are going to be up on the company?
When do you think you'll start paying attention to Piazza?
Oh,
That was rough. I'm sorry. I posted last night on Piazza the TA hours start today. So and if you go to the web page and go to I think it's the last link, it says office hours. So and I owe you one for that. What's that? There you go. There you go. Other questions?
Okay, the answer to this might be I need to pay attention to the assignment. But
Yeah.
Did it specify, like, in the main file, does that need to be, can it just be whatever we want, however we want? Or?
At this point, the main file can be whatever you want as long as it compiles without warnings or errors.
Okay.
Like, I mean, if it compiles with warnings, we may take points off. But we are not going to test your main file, right? So your main file can pretty much be anything. But don't make it silly. But I mean, it can pretty much be anything because we're going to just basically replace your main file with our own that's going to do the testing.
Okay, so we're
yeah.
using some of the main files that are coming back from the provide and like putting pieces of those in to test. That's fine if it's not like
Yes.
our code.
Yes. Yep. That's perfectly fine. So you can do whatever you want with the main file or main function, because we will replace it. Yeah. Question.
Two questions actually. If you're replacing our main file with a testing one, do we
Yep.
still have to upload a main file?
You do have to upload a main file. Yeah. Because what will happen is it will try to compile yours with your main file first. That's the first thing it does, and then it goes from there.
And secondly, how do we get the main file code you're using from Provide?
Good question. So this is not something that you will find in many. In fact, I don't think for Comp 11 anybody got the other testing files. But we're going to do a little experiment on this. When you do Provide and you find an error, like it comes up and says this test failed, it prints out the entire main function that you got tested on. So you can copy and paste that. That's how you'll get it when you do that. I'd rather not just provide them right immediately. First of all, you should be doing your own testing. and you should be learning how to do testing. We'll talk a little bit about that today. But second of all, when it goes wrong, I'd like you to have as much information as possible to know why it went wrong. That's good. Anything else? OK. All right. So we're going to talk today. We're going to talk a little bit about the homework assignment because I only very briefly introduced it. And I know a lot of you started working on it over the weekend and had some very good questions that hopefully will get answered today if they didn't get answered on Piazza. But we're going to kind of go over what dynamic arrays are. And that's the meat of the assignment 1. So we'll do that. Here's the actual schedule for today. Before I go any farther, so the labs start today. Another thing that was on Piazza, there's a pre-lab that we linked to. You should do the pre-lab before you get to lab. Now, if you have lab like this evening, you may not have time, although it's a very short pre-lab. I hope some of you guys looked at it already. But the pre-lab is basically get you thinking about the assignment that you're going to do in the lab so that when you get to the lab, you don't have to completely get up to speed. So it's kind of it's a pre-lab to say, hey, get ready for this upcoming in-lab assignment. I will try to go to all the labs at least for a few minutes this week. I'm leading one lab. I think if you're lucky enough to be in the Tuesday at 1:30 lab, maybe. I think that's me. But anyway, you'll have a lab leader and at least one other TA in the labs themselves. There are still some people, as far as I know, who have not signed up for a lab session yet. There's really only one lab section that's available still, and that's the 9 p.m. Tuesday lab. It's a late one. That lab right now only has 7 people in it. The rest have about 22 to 24. So if you want to switch to that one, you are welcome to do that as well. So if you think, oh, I didn't get my first choice, oh, that's a better lab time, go ahead and switch. Go to the same form and change your lab time. You can do that. The other thing about this lab on Tuesday at 9 p.m., that is going to be the overflow lab. If for whatever reason you can't go to your lab during the regular lab on Monday or Tuesday, go to this one. Okay, that doesn't mean you can just go to this one. You should try your best to go to the lab you're assigned to, but don't try to go to some other lab unless it's this one, because this one's the one that's more or less, very, very small attendance right now. All right, questions on that? OK, I think labs will be all right. The first lab's an interesting one. You'll see. OK, then we're going to do a couple other things. Unix tip of the day, some stuff on interfaces, which I'll describe what that means, abstract data types. We're going to talk about homework 1. I'm going to answer any other questions you have. We're going to go over a lot of details for that today. And then, in particular, dynamic arrays, and then a little bit on testing. And then if we have some time, I do want to kind of demonstrate how you would use the Eclipse debugger to debug some of your code, because some of the people are having trouble with that. At this point, raise your hand if you're still having trouble with Eclipse. And not, whoa, really? That many people? Trouble being it's slow, or trouble being it doesn't work? Raise your hand if it doesn't work. OK, I will stick around after class, and we can maybe do some things there. Go to lab. We'll try to figure that out. Question? Or you? OK. We'll figure that out. I don't know why a lot of the errors are coming up, unfortunately. It may have to do with the network drive. It may have to do with some other issues. If it ends up being something that just gets too ugly for you to figure out, then we might suggest some other options, and we can talk through other options on how to do the materials. But hopefully we'll get everybody up to speed. Most people seem to have the ability to get back going again once they did either the nuke all Eclipse and start over, or the kind of kill Eclipse thing that I set up. All right. So let's get going. The Unix tip of the day. I just wanted to, sometimes I'll do a Unix tip of the day. Sometimes I'll do an Eclipse tip of the day. Today I'm going to do both. The Unix tip of the day is 3 commands that you should probably know how to use. Right? The first is the ls command. That is just list, and I think it just stands for list, which basically lists the files in your directory. Right? So if I go over to, if I SSH into the homework server and then do just a straight up ls, right, it lists all my files. I got a bunch of files in there, right? And if I do ls-a, right, it lists even the hidden ones. And in Unix, hidden files start with a period. OK, so that lists all of them. If I do ls-al, that will list all the files in a nice format with extra information. So information about the permissions, which you probably won't need to worry about. information about who you are, what groups you belong to, other things you probably won't need to worry about, and then when the file was changed last, and the name of the file. Okay, so ls is a good command to know if you are using Unix. All right, the other one is, there are two others actually that are how you actually print out the files themselves. The cat command, right, which stands for concatenate actually. But if you do, let's see, where did it go here? There it is. If you do cat, let's see, what's a good file? Homework 1 maybe? Yeah. If I do cat and then hand.cpp, right, it will actually print the whole file to the screen and just keep scrolling until it gets to the end of the file. Okay? A better command to use is either more or less. Less is actually better than more. More came first. It's a long story. But if you do less and then the name of the file, card.cpp, it just puts enough on your screen and then stops. And then you can use the arrow key to go down and up. And then you can use the space key to go down by another page. And so it actually lets you kind of go through the file a little bit at a time. This is sometimes better than opening up an editor and saying, going forward with an editor. Okay, it's just a little easier. And a lot of times you'll use more or less. Yes?
What's the difference between more and less?
Less has more usability. Like you can't. Less is better able to go backwards in a document. I don't know why they called it less versus more, but they did. So I couldn't go up like this in more, but in less I can with the arrow keys. Okay, it's just extra functions. Yeah. All right. And that's it for the Unix tip of the day. Questions on those? We'll do lots of those. Yeah, question.
How do you exit out of the scrolling?
Oh, yeah, good question. Q, to quit. Yep. Question?
In all the references to Unix, is this from the usage of provide?
Is this from the usage of provide? What do you mean?
Well,
It's not related to provide, if that's what you're asking.
yeah, that's what
Okay. Yeah, not related. This is just how you'd actually print out a file if you wanted to see it on the screen.
I just don't recall using Unix in Eclipse.
Oh, not in Eclipse. You won't use it in Eclipse. But when you do provide, you will have to use the Unix terminal to do the provide. Yeah. Yeah. Question.
You mentioned opening stuff up in editors.
Yep.
In the command line. I was just wondering, what's your favorite editor?
These days, it's my favorite editor is Vim. Right? There's a lot of people use Emacs. A lot of people use. There's another one called Nano. There's graphical ones. I use Vim these days. Still trying to figure it out, but I like it. It does everything I need. Yeah. All right. Other questions? Yes.
With the more and less, can you edit from there, or can you just view?
You can just view. You cannot edit in those, as far as I know. I don't think you can edit, but I've never seen it done. You'd want to use an editor to do that. All right. The Eclipse tip of the day. For those of you who are having some issues, like here's what might happen. This is a scenario that I can foresee happening. You might get to a point where you say, are working on your computer and something crashes, your internet goes down, or it just kind of dies on you and you can't do anything, and you go, oh, I got to close out the window, and you get the window closed, and then you go back in to start it again, and it comes up and it says, what workspace? And it ends up saying workspace in use. What that basically means is, as far as the server is concerned, you're still using the other broken Eclipse. And so you need to kind of cancel out of that. And you need to kill that. Okay? In fact, you literally use the command kill to do it. But I wrote a little script that said that you can run by typing the following line, /comp/15/public_html/files/kill_eclipse.sh. And that will allow you to, that will basically say any running Eclipse gets just canceled, just killed. Okay, and then you should be able to restart Eclipse and it should be all right. So hopefully that will help out a little bit there. Okay. All right, we'll go through some more Eclipse tips of the day. If you ever are confused about something in either Eclipse or in Unix, you can either email me and say, hey, I don't know how to use this, or go to TA Office Hours and they may help you out with that too. Question. Yes, in the Unix terminal. Yeah, once you're SSH'd into Homework, the Homework server. Okay. All right. And by the way, if you're still having issues of like how to get into the Homework server, A, watch the video and on the Homework 0, and B, you can email on Piazza or put on Piazza or something like that. Yeah.
Is this doing the same thing as deleting the .log file?
No, this is actually killing the process of Eclipse that's running. In fact, I should probably update it to also do the delete the .log files. I didn't think about that. Yeah, it's a good point. Yeah. We'll go forward with that. And there may be more Eclipse issues as we go along, and I apologize about them in advance, but we'll give it our best shot for the next few weeks anyway until it all blows up, and then we'll be done. Yeah.
Do we need to use Eclipse for this class?
No.
Or can we use other techniques?
You can use whatever you want. If you like using Vim and Makefiles and all that, perfectly fine. If you want to use Xcode on your Mac, that's perfectly fine, or whatever editors you want. I'm happy to. I'm just suggesting Eclipse because it has functionality that I think is important to learn, like some debugging, which allows easier debugging than some other methods. But perfectly fine. Yeah?
Can you talk real quick about like the kind of Java core file thing that like pop up?
Oh yeah. So I think when something crashes on Eclipse, you'll end up with a file called, I don't have an example here, but it's something like Java core. Eclipse is written in Java, and when it crashes, it says, "I'm just going to give you whatever information, goodbye," and then it leaves all those files. So you do have, and they tend to be big files, so you have to delete them. That is one thing I didn't really expect, was how much disk space Eclipse took running. I mean, it seems like when it crashes, it takes all sorts of disk space, and just running in general takes a lot too. So maybe we'll have to talk to the CS tech people about getting more disk storage or something. I haven't figured that out yet. Yeah. OK. Other questions on that? All right, let's get into what is a programming interface. OK? So we're going to talk a lot about obviously data structures, and we're going to talk about how you create a data structure that meets a certain specification. Okay? And that's really what an interface is. Okay? An interface is a contract. Okay? An interface says, hey, your functions are going to have the following functionality. A, B, C, it's going to return this, and this is the functionality. Okay? A lot of times, the .h file doubles as the interface, right? There's a reason that you can actually get a listing of the .h files in any language you're programming in, if it's a C-based language, and look at them, because there's no details about what the behind-the-scenes function is actually doing, but there's enough details in the .h file to tell you the return values and to tell you what values the function takes as parameters and so forth. And that's what the interface provides. Okay? So the interface is just saying, hey, here's the contract for what your functions are going to provide. You get to make whatever decisions underneath the hood, in other words, in the functions themselves, that you want. Except when I tell you you have to use an array or a linked list or whatever. But if in the big picture, the interface is the generic part. You get to write the details behind the scenes. Okay? A lot of times we supplement the interface with comments about, hey, this is supposed to do this. I mean, the function definition won't necessarily tell you exactly what it's supposed to do every time. Okay? So that's what an interface is. Okay? Here's the example interface from your homework 1. This is the one for the card.h. And I haven't really introduced the homework quite yet anyway, but card.h, this is the interface for cards. And basically it says, hey, there's going to be a constructor, a couple constructors in here. And the constructors are going to, be, one is just going to be a default constructor, which just creates a card, and basically a card with a default value. And then another constructor that says it takes 2 characters. One is the rank. In other words, 2, 3, 4, ace, king, diamonds, that sort of thing. And the other is the suit, like S for, I think it's uppercase S for spades and H for hearts, etc. Right? And so that's the interface. Behind the scenes, you get to create it using however you want. It's just got to meet that interface. A couple other functions in here. Sometimes the interface, if it's so easy, will just give you the actual function right there. Right? Get suit is just going to return the suit variable, which is down here, and you're just going to say return suit. So a lot of times the interface, if it's such a short function, we'll just write it right into the interface file here, that .h file. Okay? Question? Yeah. You don't have to put it in the CPP file. No. If it's in curly brackets in the actual definition, that's fine. You do have to remember it's a semicolon, because this really is a function definition right there. Okay? All right. For those of you who have, let's see, Java doesn't really have .h files, do they? No. .h files are the interface. There's a kind of a long history about why .h files exist. part of it is that you need to have the ability to compile short bits of your code at once, because it used to take forever to compile code. Now you hit compile and 2 seconds later it's compiled, right? It used to take a long time. So what they wanted to do was have the .h files there so that if your code is already compiled, you can just look at the .h file, the compiler can look at the .h file and figure out all the function signatures and things. Like, for instance, getRank is going to return a rank type, etc. Okay? Same card returns a Boolean value, and the compiler just needs to know that information. So that's why these exist. Okay? But it's a very good way to define your interface. Okay? Yeah?
Wait, so those returns aren't just for functions in another program?
No. You mean these ones? Yeah, no, what this is saying is, OK, there's going to be a function called getSuit, which is part of the card class, right? And this function returns a suit, which is defined somewhere else, actually. And then in here, we return the variable called suit. Okay? By the way, a nice thing about Eclipse is it does color some of these things, so you can tell what it is from that standpoint as well. OK? Yep.
So if you can just declare and write out an entire function in a .h file,
yes.
I know this would be disgusting, but what would stop you from just making a .h file with nothing in your main so that all your functions in?
Bad style? I mean, I think that's really yeah, you could. I mean, as far as the compiler is concerned, the .h file is just another file with another CPP file, really. I mean, it's another compilable C++ file. But we put the .h on there so that we know that it's a header file for other reasons. You include the .h file in your .cpp file, which gives you all the function definitions. OK, so by the way, in C++ and also in Java and a lot of other languages, you have to define your functions before you use them if you are going to refer to them before they are actually written out. So this is another thing that the .h file does. It says, here's all my functions right up front, and then you can use them interchangeably before you define them, or before you actually write out the code. OK? All right. Other questions on those? All right. So let's see another example. Well, here's the same card function. So this would be the interface up here, just the name of the function, what it returns, which is the Boolean value, and what the parameter is, which is a card type in this case. Okay? And then so this right here, I guess this right here is the same thing, but and a little comment that says returns true if the cards are the same. So you are in a card, you are passed in another card, and you have to make a decision: are the two cards the same? And that's important, various times when you're playing card games, I guess. Although with one deck, you're never going to get that, I suppose. Same card. And this is how we define that in C++, for those of you guys who don't know. Right? This is the class, and then 2 colons, and then the name of the function, and the input parameter. And then in this case, we're just saying, look, if my rank of the card that I am is equal to the rank of the card that is passed in, C, and the suits are the same, then it's the same card. Return that value. Okay? And this statement right here returns a true or false value, so you just return that value. Okay? Yeah?
The reason we can use the C.rank, the private elements of the class, is because the cards double colon this is definition within the...
Yes. Good question. The question is, hey, normally you can't use private variables inside another class, but this happens to be the same class. So you can use the same. It's kind of a C++ thing. You're allowed to do that. Yeah, good question. Good question. All right. And these are details that shouldn't, I don't want them to scare you. These are details that you can write this a number of other ways, too. If you wanted to use the getters and setters, you could as well. But I just wanted to show you it this way. OK? All right. There's a hand class in your homework assignment, too. Right? Here's an interface example from this. Deal card from bottom, right? So sometimes if you have a hand of cards, you want to take a card from one side or the other, let's say. Or if you're a card sharp and you're dealing, you might want to deal from the bottom of the deck, right? And this just says deals a card from the bottom of the hand and the first card, which is the first one in the array. All right? And what it's doing is it's taking the card from this hand and putting it into, the card from your hand and putting it into the hand that you're passed in. So it's basically saying, look, deal a card from one hand to the other. Okay, and there's just some code here. Again, these are all written for you, by the way. These are all done. It's just already part of the code you were given.
Why does the h in the parameter have a little ampersand before it?
Right here.
Yep.
Why does the h have a little? Anybody know the answer to that? Yeah. Well, it's actually, you'd think it's an address. Now, this is a C++ issue that I've been annoyed at for a long time. When you have an ampersand in the actual parameter definition, it means that it's a reference variable. Now, without going into too much detail, it basically says when you are passed a reference variable, you can actually change the original copy, not the copy that was passed in. And that's, if it had just said hand h and you had tried to do this, it would have made it would have changed a copy of h, not h. So it's another C++ issue that it gets a little bit into the weeds. Yeah.
So we don't have to use pointers in order to.
For this, believe it or not, for this assignment, there's very few pointers at all because of the way we've done this.
Like the Comp 11 version of this, we would
Yeah.
have to pass the function pointers instead of.
No, you can do a reference. Yeah, you can totally do a reference, sure. Sure. And by the way, really, behind the scenes, this is a pointer. It's just hidden a little bit for you. Yeah.
So can you use that operator to turn any variable from a class method into a reference?
Yes. I mean, when you pass it in this way, it will get passed into the function as a reference, which means you are touching the original of that value instead of a copy. Yeah.
So you are kind of giving it a memory address, right?
Yeah, more or less. I mean, it's not an address, but behind the scenes it is. So, I mean, to answer your question, yes, and don't worry about it, really. Yeah.
What's the benefit of doing that as opposed to just passing a pointer to?
I think it's a little cleaner doing it this way. That's about the only difference. I mean, really, there's no other real difference than it's a little cleaner. The difference would be if this was a pointer, you would have to do an arrow notation here instead of dot notation. That's really the other difference there. Okay. All right. I didn't want this necessarily to be like C++ day, but ask your questions now, I suppose. Okay. All right. Let's go to, this is the one from, I believe, your homework assignment. Yeah. So one of the functions you have to write is this hasCard function. Okay. Now, how does the hasCard works? The cards are in an array, right? And basically, you have to look through that array and say, does the card that I'm looking for exist in this array, right? How do you do that in a C-based language like C++, right? Well, you do a loop, right? So I'd say, OK, for I equals 0, int I equals 0, I is less than the number of cards held. That's one of the variables we have, right? I++, I'm going to loop through all the cards that I have. If the cards that I'm looking, of the index that I'm at, is the same card, and remember we had same card in this case, this is where it gets useful, right? If it's the same card as the one I passed in, return true. If I get all the way through the end of the loop and I haven't found the card that I'm looking for, return false, right? So there, I just wrote one of your 13 functions for you. Write it down. And you could do it somewhat differently too, but that's the, I mean, you could technically do this with a while loop if you wanted. There's other ways to do this. But the point is you have to look through all of the array in order to find the card to see if it exists in the hand. Okay, pretty standard stuff. All right, questions on that? Good. All right, yeah, question.
Briefly.
Yeah.
No,
No, go ahead.
Just in case I missed it. That looks pretty much identical to the Java version. Is there any difference?
Yeah. Is there any difference to this than the Java version? In this case, no, I don't think so. I think it's pretty. Is it bool in Java? I don't remember a boolean or, but yeah, that's I think the only difference.
Also,
But-
you're inheriting it from the class of two colors.
What's that?
Well, you're right. You're also right. You're inheriting it from the class, which is this is a C++ part, but the function itself sure is really the same. And those of you who've done a lot of Java, that's good news that you kind of understand this syntax already. Okay? For Python people, your heads are spinning a little, right? Because this is definitely a little bit different. Okay? All right. All right. Finally, we're going to finally get to what this class is actually called, right? What is a data structure? All right. Wikipedia says a data structure is a particular way of organizing data in a computer so that it can be used efficiently. Now, I mentioned that on day one, I said our class is going to be based on making things efficient so you don't have to wait a million years for your program to end. Okay, on Wednesday, we're going to start talking about some actual analysis using a little bit more math, and you'll see that it's pretty easy to screw up and have your program go for a long, long time when you don't necessarily mean it to. Okay, so efficient is what it's all about. In a data structure, we've already said we have an interface, which says what the data structure is supposed to do, right? And we write the functions and methods that fulfill the interface, and that's what the data structure is, right? It's got some model that's backing it up, like you've got an array model. Later we'll talk about a linked list model. And this model, because you're able to manipulate that model in certain ways, you can make it fit the interface and solve the problem. Okay? And your job is to try to do it efficiently just for the individual data structure. And then later we'll talk about which data structures make more sense for their various tasks. Okay? So an array, that's a data structure. Why is it a data structure? Because behind the scenes, the array is memory addresses where you put actual information. You put data in those spots in memory addresses. Okay? One memory address after the other is what an array is. Okay? A linked list is also a data structure. Why is a linked list a data structure? Because, and we haven't, if you haven't done linked lists before, this is kind of the first thing. I got a little box here, right? And this box has some data in it. And it also has a reference or a pointer to some other box, which is the next item, right? And then that has its own data. And then that points to another item, right? And this goes on forever. The nice thing about linked lists is that these items don't have to be in order in memory. One could be, if our array was here with 4 boxes or 5 boxes in it, right? The first element could be in box 1, right? The second element could be all the way in box 5, right? And then the third element could be somewhere right next to it, behind it again in some other position. And that's how linked lists work. So it's a different model. Remember, at the end of the day, everything's in an array. But when you talk about the model that you're dealing with, the linked list in particular doesn't have to be in order like that. Okay? We'll get more into detail on that next week. Okay? But that's what data structures are. Okay? Data structures are just the model that backs up your interface. Okay? Compare the data structure to what we call an abstract data type. Now, I'm not going to stress this too much, but you should know the difference. Okay? An abstract data type is basically the abstract part of this interface that you're allowed to do the back-end stuff for. I mean, in some sense, it's very, very similar to the interface. But Wikipedia, unfortunately, they use the word data structure in this definition, which I don't like. But Wikipedia says a data structure that is defined indirectly by the operations that may be performed on it. That's where an abstract data type comes into play. An abstract data type says, here are the types of things I am going to do. You figure out how to do them. Notice that's very similar to an interface. Okay? I'm going to tell you what types of things I want to be able to do, and you get to do them however you're going to in the behind-the-scenes functions. Okay? The interface defines the abstract data type, and it's the kind of the notion of the operations. Okay? Under the hood, that's your problem. Okay? I see a lot of people writing these down. These slides are all online, by the way, in multiple formats. So don't necessarily worry about getting every word down. Although I do hear that research shows that actually writing some things down does get things in your brain better, for what it's worth. Okay?
I have a hunch that won't resonate with me if I just write it down as it is.
What's that?
I have a hunch that's not going to resonate.
Oh well, yeah. You do have to. Do you get the idea that we're talking about? Here's a bunch of functions we want to do. Behind the scenes, when you're figuring out how to do those functions, you get to decide that. That's the big difference between an abstract data type which says, I want to be able to insert at the beginning of a list. I want to be able to remove at some index. I want to be able to insert at the, or append to the end of a list. Those are all abstract notions of what's happening. Behind the scenes, you say, OK, there's an array with 5 items in it, and I'm going to insert at the beginning. So I need to figure out how to get 5 of those items moved over one, and so forth. The details are really the data structure part of it. OK, that's the big difference there. Right. OK. Here's an example from homework 1. The list. Now, homeworks 1 and 2 are almost identical. From an interface perspective, they are really virtually identical. There's like going to be 2 variables different in the .h file, right? Otherwise, you have to write the list functions for the first assignment using an array, for the second assignment for using this linked list thing that we talked about. Okay? And so the list partially defines the interface, right? And any way you can figure out how to do that, that's the data structure part of it. Okay? Insert at head, right? Insert at head for a linked list is significantly different than for an array. In fact, it's very easy to do on a linked list, right? If you know where the beginning of your linked list is, right? We have this thing called a head pointer, which says this is the first one in my linked list, right? All you need to do is take the head pointer and point it towards your new item that you're inserting, and then point the follow-on link to the one that used to be the head, right? And that's all you need to do for a linked list. We'll get into more details about that next week, right? For an array, well, if you've got an array, and let's say this little thing on the board here was not a linked list anymore, it was an array. If you want to insert at the beginning, you got to move everything over one and then stick it in there, okay, in general. All right, so there's the differences are all about the type of data structure and how you're implementing it behind the scenes. Okay? Declaration, exactly the same. Function declaration is the same. You don't need any other different, you just need to write the code differently to be part of your data structure model. Okay, questions on that so far? All right, good. As I said, assignments 1 and 2 are very similar. Most of you guys have already looked at this, great. Based on a deck of cards, which I've kind of been mentioning here as we go along, we've written 2 classes. One being the card class. Okay, if you've never played cards before, well, you should start because it's fun. But in a deck of cards, obviously you have suits, clubs, diamonds, hearts, and spades, right? And you have the ranks, which go from 2 all the way up to ace. And sometimes, depending on the game you're playing, ace is like at the beginning, right? So it depends on what game you are. Poker's a weird one in that you can have a straight that begins with ace or ends with ace. But you can't wrap around. Like you can't have king, ace, 2, 3, 4. Like that's not a straight. But in poker, you can have ace, 2, 3, 4, 5, or what is it, 10, jack, queen, king, ace. So anyway, it depends on the game. But we have defined these. We've defined what we call an enum, which if you're in Java, you probably used enums before. C++, you don't use them quite as much maybe. But we basically defined them so that the suits are just club, diamond, heart, and spade. And underneath the covers, they're just integers. And then the ranks are all the way from 2 up to ace. Okay? Keeping in the abstract nature of things, a hand just contains all these functions that organize the hand. A deck of cards is considered a hand in the sense of this model, right? You've got 52 cards. They're all there. And you can do all the same operations on a deck that you can do in an actual hand. Okay? Question?
I know in the header file we were looking at earlier, you had some data type suit and rank.
Yes.
Where is that?
I believe that's actually defined in the card.h file. I just didn't put it in this one, in this definition here because of space. So I think it's up above, I believe. I think it is anyway, in the card definition. So you'll see when you open up card.h, you'll see. It's an enum, which says basically the following words mean the integers 0 through whatever. Okay? All right. But you can refer to them. It's nice to be able to refer to them in kind of human words instead of numbers. Because I don't remember what the number for an ace is, right? And by the way, the number for 2 is 0. So you don't want to have to try to do that translation if you can help it. Okay? All right. Hand, contains a private data member called list_dynamic_array, which is a class which is the one that you're going to be writing the functions for. Okay? This is so that when we get to assignment 2, this is not going to be list_dynamic_array anymore. It's going to be list_linked_list, right? Or something like that, because you're going to just change the back end of things. But all the other functions are going to be the same, because they can be. And that's the whole point of going from an abstract description, the interface or the abstract data type, to the actual data structure. Okay? All right. Some other things you can do with hands. Now, I built most of these for you. If you get through this assignment and you want to do more stuff, like I didn't actually make this card do any game, like it doesn't play any games yet or whatever. It's just kind of generic hands. If you want to get it to do something, you can add more functions in the hand class if you want. Don't change the ones we've had, but you can add more if you want. And these are the ones that we've already put in there for you, right? You can, as we showed earlier, you can deal a card from one hand to the other, right? You can add cards anywhere in the deck, either the beginning or the end, or at some index in the middle, right? You can remove cards. You can shuffle a hand, right? Which would basically be what you want to do for a deck of cards, right? Shuffle the deck, right? Or if you're playing War or something. I don't know if you played that game before, but you shuffle your hand before you do it, right? And then you can, or there's also a couple other functions. Like if you're playing a game where you have the order of the cards makes certain functions, well, we are able to order the hand based on a couple things. These are things you're not actually going to have to worry about for this assignment, right? They're there. You can look at them. They do the stuff in the background, but you don't have to actually worry about them. But I wanted you to see kind of a more full program for these, OK? We saw that you could check if a card is a hand, and you can print out the hand. The printing out the hand is kind of an important one for this one, because that's how we're going to test your code in many cases. We're going to try to do some function like insert at the beginning, and then we're going to print out the hand and see if the card that we just put in is at the beginning, right? That's the way it works. Okay? And all that already written for you. Okay? And later assignments, you're going to have to write some of these things as well. But for the first couple of assignments, I didn't want you to have to do too much like down and dirty background information stuff. And again, in this class, we're going to try to focus on getting you up to speed on the data structures themselves. And if we kind of wrap that in a bigger program, well, that's just because it's more interesting that way. Okay? All right. So here's all the stuff we have to do, right? There's like 13 different things you have to write. And I already wrote one for you earlier today, right? Some of these are very easy, like one-liners. The constructor and the destructor. Destructors, we're going to have to talk a little bit more in detail about destructors at some point. But the destructor basically is the cleanup at the end of the class. When you're done with the class, most of the time it's when the program ends. Sometimes it's just when you actually hit, when you use the delete keyword. The destructor gets called. But the destructor is just cleanup, right? And the constructor is constructing the class from the standpoint of setting up the variables, initializing a hand, for instance, or initializing a card. Okay? Initializing a, in this case, dynamic array. Right? We'll get to more details on that in a little bit. Okay? And then there's all these other functions. And we're going to kind of go through how these functions relate to dynamic arrays as well. Okay, one of the key ones here is this expand function. This one is necessary because of the way dynamic arrays actually work. We'll talk about the expand function in a little bit, and you'll have to write an expand function in lab for a dynamic array and for this. So you'll get lots of practice. And I'll almost certainly ask about it on the midterm. Stomp, stomp, right? Okay. All right. So as I said, this is more like assignment 1 stuff. This is, I think, this slide was the same one as on the first day. I just copied it because we didn't get to go over it. You have to meet the requirements of the .h file, right? And if you have questions, we've already seen some on Piazza about not understanding exactly what the requirements are, then put it on Piazza. I will try to do my best to put things in comments that are unclear. Sometimes I'm not very good at it. We've given you lots of comments in this code. Somebody asked on Piazza whether or not you had to comment more. I'm not particularly worried about that for this assignment because we already gave you a lot of comments. There are probably places where you could add a few more comments here and there, like what you were thinking when you were doing this. But commenting in itself, please don't over-comment. You do not need to have 4 I equals 0, I is less than 10, I plus plus, and then slash slash, right, for loop. Right? That, I mean, yes, that's a comment, but that is not a comment that makes any sense in terms of like readability or anything else. Like I know is a for loop, I can read C++ code, right? I mean, it's not that, right? You want to say something like looking at each card to see if it's the same, or something like that, to like be more explicit about what you're doing or why you're doing it, not that you're doing a for loop, right? Don't do those kind of comments. Yes.
Similar note for commenting to the README file.
Yep. README file is a little different. Go ahead.
There was parts where it said like sometimes we'd be asked to talk about our algorithm and sometimes it wasn't required.
Yes.
For this, it's like a whole bunch of kind of. Do you want it?
So that's good. That's a very good question. We'll do a little side thing on README files for a minute. So you will always have to put together a README file for the assignment. We'll generally give you a template of some sort. It happens to be in a cool markup code. If it's .md, it's markup, but you don't have to worry about that. You can just make it straight up text. You do not have to put comments. I mean, it's not a C++ file, right? You can just put a paragraph or whatever. But what we want the README file to do is describe a couple things. First of all, it's supposed to list the files that are in that you've submitted, right? Second of all, it's supposed to say, how do you actually compile this? You're going to always say, use the provided makefile. That's all you're going to say, right? That's fine. Okay? Or you could say I used Eclipse, but I mean you're going to, in general, you just say use the provided makefile to make this program. And then you're going to just say a few words about what the program does. In this case, you'll probably want to say, for this program, we implemented the the dynamic array data structure, and based on the interface file, and it has the following functions associated with it. And you don't need to list them all again, but I mean you could say, we can insert cards, we can remove cards, etc. Okay, that's about it. Okay, the README files do not have to be long. They just have to be descriptive enough so that if I didn't know what your program was about, I could go to the README file and it would tell me at least a little bit about it so I could get up to speed. Okay, other questions on the README file? Not hard to do. Just text editor works fine. You could probably do it you could probably change it in Eclipse. That's fine too. Okay. All right. Tests. All right. We're going to go over some more tests later. I've said this. I said this on day one. I said it again today. I'm going to probably say it every single day. You need to write some tests for your code. What do I mean? I mean write some C++ code in a main function that actually tests whether or not the functions you wrote work. You have to figure that out, right? And if you say, I don't know if how I'm going to test that, well, then you probably don't really understand what your function's actually done, right? So I mean, once you understand what your function's done, writing a test for it should become second nature after a while. You should be able to write tests for it. We try to write the most simple tests we can to kind of weed out other problems. And sometimes that's tough because sometimes you need more functions to actually test the one you just wrote. So it gets a little tricky sometimes, but you generally can write small enough functions that do it. Okay. As I said, we're going to run some tests during the provide stage. When you do make provide, and then you answer yes that I'm ready to go, right? We will compile your code and then run our own main functions. We'll probably try to run your main function too. So let me think about this. If we run your main function, if you have input, it may crash because we don't know how to do the input. So you probably might want to avoid that, or maybe we won't. Maybe we'll just do it so we don't even run your main function. But either way, we will run a number of tests that you will then see, as I said before, if your program fails those tests. So it's part of it is so that you get used to seeing what a test is and how to maybe run your own. And then the second part is, oh, my program's broken. I better fix this part. Okay. All right. We may run other tests as well. The other tests are just other things we think about. They're things that maybe we want to take longer to run than just right when you provide it. Maybe it'll do corner cases that we thought, hey, you should think about on your own and that we didn't want to test right now. Other tests as well. So just because you provide successfully doesn't mean you will necessarily get 100 on the assignment. Okay? And formatting your code is important. Look, Eclipse does this for you, right? Most editors will actually do this for you these days. In Eclipse, if you type Control-A to select the whole file and then Control-I, it like perfectly formats your file for you. right? It does all the tabs right, it does all the curly brackets, and it's nice. We don't want your code to be what we call obfuscated. In fact, anybody ever heard of the obfuscated C contest? Yeah, so there's this contest. Maybe on Wednesday I'll show you some details about that. But there's this contest that says, try to make a C program so confusing that you have no idea what it's going to do before it does it, and then make it do something really cool, right? And that's the and people have a lot of fun building those, right? They're like wicked hard to understand. Right? I'll show you on Wednesday. I'll show you some details of the obfuscated C contest, and it's very impressive, very impressive. Okay, questions on that? Assignment 1. Okay. Again, if you breeze through this assignment, great, right? You're on track. What I don't want to hear is in the midterm reviews. You can say whatever you want. One second. You can say whatever you want in midterm reviews, but if I hear the class is too easy, well, then you didn't try hard enough on your own, like going farther than you need to in this sense. Okay, I'm trying to make programs that all of you can program, and then if you want to go farther, by all means, and tell me about it in the README file because I want to run it and I want to see how cool it is. Okay, if you write a little like poker playing robot or whatever, great, tell me about it. Right? Question.
Yeah, in the comments in the functions, we have to follow what the comments are.
So the comments in the functions are the way I would program them.
Okay.
If you have a better method and it's still got to be an array. Like we're going to look through your code and it's got, but if you say, oh, I can do this slightly differently, I can go through the loop a different way, or I can, fine. The comments were basically in this case to make you so you don't freak out about the assignment. That's like the big thing now. Okay. All right. And if you are freaking out about the assignment, go to office hours. They start today. Actually, they've already started. Anybody gone to office hours yet? No? Oh, I guess some TA got paid for doing nothing. Oh. All right. We'll change that. All right. But that's the other thing. We are going to try to adjust the office hours for times that you'll be in the lab. This Friday, so this assignment's due Friday night, right? I think office hours right now end at 6 or something like that, or so 6 p.m. and the assignment's not due till midnight. So we may try to get some more TAs in there, but my other suggestion is try to finish it Thursday or Friday during the day. Yeah.
Say it's due Friday midnight?
Friday midnight, I think, yeah.
So,
Or did I say no? I think it's Friday midnight. Maybe I'll make it Saturday. We'll see.
so would that mean at the very Friday early in the morning or Saturday or?
Well, yeah. Look, if you're a few hours late, I'm not worried about it. If you do it like Saturday morning at 6 a.m., I'm not going to dock points off, right? If you wait till Sunday and I still haven't seen it yet, well, then I'll probably take some points off, right? I mean, probably sometime Saturday too. I mean, it's use your own judgment. But if you're like really late, email me and I'll work out on an individual basis like what the issue is. Sometimes people have sporting events, they have other things they have to do, they have this and that, and sometimes there's things come up, and I get that, right? I understand you guys are super busy, you've got a million things on your plate, and sometimes you have to prioritize, and let me just say up front, I think data structures is an awesome course, and I think you should do a lot, work hard on it, but I know it's not the only thing in your life. Okay? Let me put it that way. I know it's not the only thing in your life. That said, I also know you're tough students and you're going to work hard on this. So there you go. Question?
If we are going to do something extra with it,
yeah.
Can we just make that our main file instead of giving you our tests, or do you want to?
You can do it to make that your main file. Yeah. I mean, again, I'm trying to figure out how we're going to do. What I don't want to happen is when you provide it stalls because it's waiting. Your program's waiting for input, and we don't know to give you any input, right? So don't make your program have any input. Well, that's harder said than done, I guess. But maybe I'll go and change it so it doesn't even run your program. But I want to be able to test your program. If you say in the README file, hey, I made it do this, I want to test it. So I'll go do it. Tell me how to run it too. Like if it says, if you say, hey, you're going to need to input 6 cards, then tell me how to do that. Whatever. Okay? All right. Other questions on that? Having a hard time? Go to office hours. Okay. All right. Now that we've described the dynamic array homework assignment, let's talk a little bit about dynamic arrays in general. Okay? Dynamic arrays are, as I said, a bunch of addresses in a row that you get to put information in. And they are what the computer knows at the very basic level, like at the base level. Okay? So in this little table here, there's just 4 addresses in a row. Address 1, address 2, address 3, address 4. And that's the array. Okay? an array can be pretty much any size up to the amount of memory that the memory system is willing to give you. That depends on what operating system you're running and what computer you happen to be on and so forth. But an array is just one long list of addresses where you put data. Okay? In C++, we have a couple different ways to get at that data. Okay? In Java, you have basically one way, right? It's this little bracket notation that says x bracket 2 is the third element of the array, right? In C++, the definition of the variable that says where that defines an array is actually a pointer. And in C++, we use the star notation for pointer. And that says, hey, if your array is this box of 4 items, and you've got the variable that defines that, that is going to point to the first address. Okay, so if we have x here, and x is some value, x is going to be an address that you will probably never see. Like, you don't care about the actual address, but you have to know that x does point to that address. And what's cool about that is x plus 1 points to the first address after the second address. If this is address 0, address 1, 2, 3, right? X points to the first address in the array. X plus 1 points to the second one. X plus 2 points to the next one, and so on. You see what I mean? That's how this actually works. So you can say, in this case, main int capacity equals 10. We'll talk about what that means in a sec. Int star x says, I'm going to give you a pointer that's going to point to this array. The new keyword says, I want you to give me enough memory for the array I asked for. It's of integers in this case, and it has the size of the capacity. So these two lines together mean that we're going to have 10 addresses in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 addresses in a row, 0 all the way up to 9. And that's your array. At this point, can you tell me what's in these little boxes? Is there anything in there? There's what? Dead squirrels. Yeah, I guess that's what you called it in last class in Comp 11, right? There's nothing you can count on being in there. It's just random data that you can't count. It's not zeros. Java makes it zeros, I believe. But C++, it's whatever was in the memory system before, right? Which makes security a bit hard, incidentally. Okay? And then this next line here, the x bracket 3 equals 12, says, OK, go over to in this case, the fourth item over, right here, and put 12, right? And the next one here, this is the pointer notation. Star x plus 2. Well, we said x points to 0, right? X plus 1 points here. X plus 2 points here. This one, we say equals 5, and that's where 5 is going to go. OK? Now, again, this is your array. These values, 0 and 1 and 4 and 5 all the way up to 9, are random data you can't count on. The only ones we know right now are 5 and 12. For your homework, you're going to want to specifically go from 0, 1, 2, 3, and up, so you always know where your real data is. OK? All right. So what's the output of this going to be when we say C out and then star x plus 3? What's that one going to print out? 12, because that's the same as x bracket 3. And then x bracket 2 is the same as x plus 2. And that's going to print out 5. OK? See how that works? Blank. We have no idea. That's why there's a question mark here. Question mark 5, 12, question mark, question mark. Question. Not mark. Yeah.
Since you can change the size of the array well enough, wouldn't it be more efficient for your memory just to have an array only for the size of the data you have?
Good question. Should you only have the array for the size of data you have? Yes. It's not always possible to do that, number one. And number two, if you had an array of if you had an array that was one box big, right, and then you added something else, unfortunately, C++ doesn't say, I'm just going to extend this for you, right? You have to actually create a whole new box. And if you want to make it 2, you've got to create a whole new one, copy the data over, and then assign this one. That's inefficient. What you might want to do is make it big enough so you can big enough to start with, and then expand it as necessary. OK? We'll get into that a little bit. OK? All right. more on dynamic arrays. So, and this goes exactly what you were saying here. Our initial array had 10 elements in it. When we defined it, we said, give me an array of capacity. And that capacity was 10. It had 10 elements in it. And when we get to the 11th element, we have to do this procedure where we expand the array by getting a new one, copying the data, deleting the old one, and resetting up the new one to point to the array to point to the new location. OK? So that's how we're going to do it. And I'm going to go through the details of that here. But we have to create a new one. That's part of the time it takes to deal with dynamic arrays. OK? They're very fast, but when you have to expand them, that takes time. OK? There are 5 steps to expanding a dynamic array, kind of what I just said. OK? If we start with 10 items, OK? First thing we do is create a new array with a new size. In Comp 11, you probably thought about what a good size to go to was. If I start out with 10 elements, what's the next size I want to go up to? 20 elements. So what's the next size after that? 40, right? You were generally doubling this. Why are we doubling it? Well, some pretty smart computer scientists did a lot of studies and figured, well, or a lot of thinking, I guess, and both empirically and kind of from a research perspective, they said, yeah, doubling it's a pretty good idea. Yes, you get twice as much space, and if you happen to only add one more element after you've expanded it, you're wasting a lot of extra space, but you didn't necessarily know that ahead of time. Okay? So that's what we do. So now instead of having an array of 10, we would have an array of 20. I'm not going to draw all this on the board, but it's an array of 20 elements now when we do the new command. Then you have to copy all those values over. So what you're doing is you're going through the original, copying all the values into the first 10 spots. And now you've got your new array, but there's still more cleanup to do. The cleanup happens in the following way. You delete the old array. This tends to be really confusing for people. OK, I'll show you on the next, I think I show you on the next slide what it is. Yes, I do. On this, I'll go back to the other one in a sec. But in this case, here's what we did. We created a new array, right? And it's twice the capacity. Then we looped through all the elements in the old one and copied them into the new one. We've said new x plus I equals the original x plus I. In other words, copy everything from one array into the other. This says delete the information that x points to. This little bracket thing says it's an array. Hint, hint, it's an array. Right? This says delete what x points to. Are we deleting the variable x? Say no. Right? Yeah, we do not. There's no like concept of deleting a variable. You're deleting what it's pointing to. OK? So when we start out, x points to this first array of 10 elements. We create another array of 20 elements. We copy them all in. And then we say, we don't need the old one anymore. Delete it. That's what this one's doing. Then we say, the variable that now points to junk, which is x, we just deleted it. It points to junk now. We can't guarantee anything about it. But now we want to say, hey, don't point x. X used to point up to the first array. Now we're going to change it and say, point to the second array. See how that works? That's what's going on when you're deleting the stuff in x and then pointing the variable x to the new array. You don't delete the new array, because that still points there. Right now, let me go back one step. X pointed to the first array. New x pointed to the second array. This statement right here, x equals new underscore x, makes x point to the same thing that new underscore x points to. So now both of these point here. And you don't know how many times I've seen people go and delete this one because they think they're doing something they need to do. No, if you said delete new underscore x, you erase this whole thing, and then your program crashes. Right? Question, then question.
OK. First, is there any way
Oh, sorry. Go ahead. Go ahead. We'll get to you next. Yeah.
Sorry. Is there any way to delete new x, the pointer, without deleting the array?
No.
Oh, OK.
No, you're not going to do that. It's going to do it. The compiler will do that at the end of the function.
And secondly, in the destructor method, when we delete the array, do we have to delete the pointer as well?
Nope. You just delete the, there really is no concept of deleting the pointer. Don't worry about that. You're deleting the stuff it points to. That's what delete means. You're pointing at something, I'm deleting what you're pointing to. That's what it means.
So no deleting pointers?
Don't delete the pointer, and don't even think of that. There's no such thing as deleting a pointer. You're deleting the stuff the pointer points at. Question down here, and then I'll get to you in a minute. And there'll be one thing. Yeah.
So at a low level,
Yep.
you aren't actually the delete thing doesn't even remove the array though. It just pretends it. I mean, like,
Yeah.
it's still there,
Yep.
most
Yep.
likely
And at the lowest level,
occupied.
right? It gives it back to the memory system and says you can use it for other arrays. That's it. Yep.
When
then
you
back
use the delete, is the x, is that x set to the null pointer?
Nope. The x is not. The x still points to the same thing. Yep. X still points to that now garbage. Is what it points to.
If you called x, would you get back the data from the original array if you left?
Most likely you would, right? You cannot guarantee it, but most likely you would. Yeah. Other question back there and then here. Yeah. Yeah, you.
So for the destructors, should we assign pointer to null then if we don't want to use it?
You don't even need to. For the don't worry about that. We'll talk about destructors a little later. Don't worry about that though. Yeah. Same question.
So if for some reason you didn't want that data just going back into the,
Yep.
like, because you didn't want it showing up somewhere else, is the only way to just fill it with null values?
Yeah, fill it with zeros. In fact, not null values. Be careful. Even though 0 is null, in this case these are integers, so they are not null values. They're integers. So you would fill it with bogus data, your own bogus data. Security people worry about that all the time.
It could just show up on somewhere else.
Yeah. This is how so there have been some very high-profile hackers who have been hacking away at their computer, and the police are getting pretty smart these days. They will basically literally burst into a room of some hacker and like tackle him so that he can't turn his computer off. And then what they do is they wrap the computer up and they don't even turn it off. Like they bring in like other hackers, the police hackers, and they go in and they dump the entire memory into their disk, the entire memory. And then they go back and look through it, and then they find passwords and they find stuff that's in memory still that there was nothing you could do about. So it's, I mean, it's pretty clever in that sense. But you know, if you needed to delete something, you should probably overwrite it. Yeah, good question. All right, other questions on that? Everybody think that, well, I'm quite finished up with what you have to do here. Delete the old array, point the old array variable to the new array variable, and then update the capacity. Don't forget to do this, right? What we've done here, take a look at this. We said, now we've got a new array with twice the capacity. At this point, what does the capacity vary? If the capacity was 10, after we say this statement, what's the capacity? Still 10. We didn't change it yet. That happens way down here, right? When we say capacity times equals 2, that says now update our capacity. The capacity variable is bookkeeping. All it says to us is now we know how big the array is and when we're going to need to expand it again. Okay? All right. Now, today and tomorrow in the lab, you're going to have to write something very similar to this. There's actually a copy in a different function already there. You can go pull this up. I mean, this is not, I don't want to make this sneaky, right? You do the same thing every time you're expanding a dynamic array. Create a new one twice the size, copy the data, delete the old one, the stuff the old array, or the stuff that the array pointer points to, reset that to the new array, to point to the new array, update the capacity, you're done. Okay? And then you can say, now you can use the value farther up in the array. Okay? All right. Okay. More functions that you're going to have to look at. We already looked at most of these. We looked at them before. Okay. I want to talk a little bit about how to actually, let me see. Let's discuss how we implement some of these. Okay. Let me open the floor. Did anybody have trouble implementing any of these that they didn't know exactly what I was asking for these? Yeah.
Yeah, the remove from tail.
Ah, good question.
So
Yep.
I read the Piazza post and
Yep.
you said that you should just, I think you said like change the value
Yep.
for card's held. You just literally mean subtract 1.
Yep, watch this. There's 3 variables here you need to worry about. Okay? There's I believe it's card. It's hand, isn't it? I think it's, is it cards? It is cards. You're right. Okay. Cards is a pointer to the array. Okay. There's also the cards underscore held, which tells you how many are in there already, like how many you've been dealt, basically. Right? There's also, what is it, card, is it hand capacity? Yeah, hand capacity. And hand capacity is just what tells you how much space you have. When those two things are equal, that's when you need to expand because you would run off the end if you tried to insert. Okay? Now, hand capacity for this array that I have on the board, it's 10 elements long. What's hand capacity going to be? 10. Okay? In this case, 2, 3, 5, and 12. What is the number of cards held? 4. Okay. If you kept adding, by the time you got to 10, you would be trying to add here at the end after the array, and you'd need to expand. That's when you do the expand. Okay? All right. Remove at, which one is it? Remove from tail. Which one's going to go away in this case? 2, 3, 5, or 12? OK. We're trying to remove that one, not the one at the end. There is nothing over here. Even though this array is 10 values in capacity, the last value is the fourth one here because that's 2, 3, 5, and 12 are the only values in the array. Okay? For removing the last one, in this case, cards held is 4, right? All you need to do is make cards held equal to 3, right? And, well, you should probably check one thing first. In this case, you definitely need to check if you're at 0. Because you can't remove a card from 0, right? That should probably crash anyway if you tried to remove a card from a 0. But don't worry about that part. But in this case, if cards held is now 3, how many elements are in the array? How many cards do you have? 3. Which cards are they? 2, 3, 5. Is 12 still a card that you hold? Nope. Is it still in memory? Yeah, who cares, right? It can be bogus. It's bogus now. Even though it's still there, it's bogus, even though it's still there. I mean, the point is that this cards held tells you where your cards are. They're the first 3. In this case, if cards held is 3, the first 3 elements of those array are all your cards. 12 does not count anymore. You do not need to make it 0. There is no concept of making it null. Don't need to make it 0, whatever. Okay? And by the way, these aren't cards. These are numbers. Cards are ace, ace of hearts or whatever. But in this case, that is an empty card as far as we care. Okay? Did the hand capacity change? When you removed at the tail, your hand capacity doesn't change. I don't care that you don't need to make it smaller just because you've removed a card. The array can stay as big as it wants, or as big as you make it. We do not need to go backwards. If you are writing a program of your own and you know you're going to be adding a whole bunch of things, then deleting a whole bunch of things, and adding a whole bunch of things, and you want some extra performance, sure, maybe you will delete the array and copy into a smaller array and delete it. But do not worry about that for this class. Okay? Good question on that. Yeah.
So for removed from index,
yeah.
Does the index start at 0 or 1?
What do you think?
Well, my thought was that if you ask for like a position, and I say like I want the first element. Yeah.
Right. I would assume you're not a computer scientist, right? I mean, so the answer to your question is 0. We're gonna index everything by 0, just because that's the way the programming language does it. We don't want to try to mess with doing it different. So yeah, very good question. If I remove at index 0, in this case, if 2, 3, 5, and 12 are the elements in my array, remove at index 0 is removing 2. Removing at index 1 is 3. Okay, very good question. Okay, yeah, go ahead. Yeah.
Arrays. But so when you initialize an array, X has so many capacities, and then when you're, the brackets are the dereference operation for the array. Can you use an asterisk dereference operator on X to get the very first element?
Absolutely. Yep. That means the first element. Yep. It's just like doing X plus 0. I mean, it's the same thing, right? You have to remember the parentheses in that case. Remove from at index. Remember what now in this case, you can't just change the cards held. If we go back to having 4 cards, 2, 3, 5, and 12, if you remove at index 2, the 5 is going to go away. But what do you have to do with everything above 5? Move it back into that position. So you can't have a blank space. So you would have to do a loop through all the rest of the elements up to cards held. You don't need to do all the way to capacity, just the ones you hold, and then move them down. OK, that's just a loop. All right. OK. Other questions on these operations? OK, I think we don't really have time to get into the how to test your code. the homework assignment gives you a basic test. At least it shows you one test. You can look at the rest of the comments on the or on the slides about this. All right. OK, I think that's about it. If you have questions about your computer, come on up. I'll stick around until they kick us out. And we'll talk to you either in lab or on Wednesday.